Our universe is 13.7 billion years old and was not as vast as it is today. In fact, our universe is expanding every moment. Using the observatories on the Earth and in space, astronomers have been able to study the nature of cosmos in an unprecedented detail. By analyzing the motion of distant galaxies, we have discovered that the whole cosmos is expanding under the influence of force unleashed at its birth in the Big Bang. So, how exactly did we get here? And what are the possibilities in the far future? Well, let's find out. In the first picosecond of the cosmic time, universe is thought to be incredibly hot, dense and turbulent, with very fabric of space and time turning into a muddy swamp. All the fundamental forces currently at work in the universe like gravity, electromagnetism and strong and weak nuclear forces are thought to have been unified during this stage into a single superforce. This phase of universe after the Big Bang lasted for around 370,000 years. Initially, various kind of subatomic particles were formed in this stage, including protons and neutrons. Around 20 minutes after the Big Bang, the universe was no longer hot enough for nuclear fusion, but was too hot for neutral atoms to exist. At around 47,000 years, the behavior of universe began to dominated by the matter rather than radiation. At around 100,000 years, the first neutral helium atom was formed. At the end of this era, about 370,000 years after the Big Bang, a neutral hydrogen was formed and the universe started to become transparent for the first time. That means the first light as we know today was formed at this point. This is also the oldest observation we currently have of the universe. Once the universe became transparent, the clouds of hydrogen collapsed very slowly to form stars and galaxies. The photons released during the decoupling of neutrinos in the early universe phase would have filled the universe with a brilliant pale orange glow at first, but gradually redshifting to a non-visible wavelength after around 3 million years, leaving it without a visible light and earning itself a name of cosmic dark ages. It was in this period when galaxies, quasars were formed. Subsequently, galaxy clusters and superclusters emerged over the time. The universe gradually transitioned into the universe we see around us today, and the dark ages came to an end around 1 billion years after the Big Bang. After the dark ages, the universe has looked much as it does today, and it will continue to appear very similar for millions of years into the future. Our solar system was formed around 4 billion years from today, with the earliest traces of life on Earth emerging by around 3.5 billion years before. It was in this phase when the universe reached its inflection point, and the universe entered the modern dark energy dominated era where the universe expansion is accelerating rather than decelerating. As the universe will continue on expanding, the stelliferous era will end. The luminosity of galaxy will begin to diminish, no new star will born, and the temperature will eventually become too cold to sustain life. This scenario is popularly known as Big Chill or Big Freeze. After that, all the stellar remnants in the universe will fall into a black hole. And as there is nothing to consume, the black holes will perish as well, which will effectively end the universe as we know.